Hello and welcome to another edition of James and Chris Science Videos, where today we're going to be looking at graphing in a slightly stir-crazy COVID-19 situation. So here we go. Without further ado, let's look at what the Key Stage 3 and ISEB Science syllabus say about graphing. So there are two types of graphs that the ISEB syllabus says that you need to know. The two types are bar graph. Now here's just a little example at the side. And the second type is a linear graph or line graph, of which again another example is here at the side. Now the purpose of this video is to talk you through which one you should choose, and then I'm going to talk about how to build and to draw a linear graph. So how do I choose which graph to use? Well, the answer to that is covered in a previous video, but it's about the type of data you've got. And if you remember, there are two types of data. There's continuous data and there is discontinuous data. So we'll start off. If the data I've got is discontinuous data, so here's some made up results. Here is what I'd imagine the people in my lessons think about lessons, and they are your favourite lessons: English, Maths, Geography, French, History, Science, and I've put the percentage of children that think that that subject is their favourite. Now, why is it discontinuous? It's because they are discrete groups. You're either in English or Maths or Geography, you think one or the other, and they're kind of in boxes. So if you've got this discontinuous data, this data that fit into categories, then the only graph you can do for that is a bar chart, a bar graph. Why? Because each bar represents that different categories. There's no linking between the two. There's no kind of following through. And so you look at that and you can actually move each of the bars around. It doesn't matter which order they go. You could have had history first or science first or French first. It really doesn't matter. You represent the data in those shaded bars that go up, and then you match it to the number that is on the y-axis. We're going to talk about x and y-axis in a second. So every time you've got discontinuous data, you should go for a bar chart. So continuous data, we are looking at a line graph. And the line graph that I've shown here is for one where I've talked about massive baked beans that I might have eaten, followed by the amount of methane that I'll probably produce the next day. So you can see a direct link there. There's 100 grams of baked beans equates to 0.4 litres of methane. Completely made up results, but you get the idea. Now, the reason that we use a line graph is because the line graph has all the numbers in between. So, for example, it is possible for me to eat 150 grams of baked beans, in which case there'll be an answer between 100 and 200. Now, we talked about it being on a number line, and so we're actually going from 0 to 600, and theoretically I could have a result anything in between. So, any kind of data that is continuous in that manner, then we have to use scatter graphs or line graphs in order to express the data. So let's look at making a linear graph and show you the steps needed for that. Okay, so here is my data that I showed you in the previous slide. I've got my mass of baked beans, and again I've got my amount of methane produced. So let's talk about setting this up in a graph and how we can do this successfully, because in terms of common entrance or Key Stage 3, there's usually 4 or 5 marks available for this. So it's heavily weighted towards knowing how to do these graphs. So let's have a look at this. I'm doing this on OneNote because it's easy for me to explain and to draw. So here is OneNote. I've got my x-axis and my y-axis. So basic graphs, you've got two axes that we're going to talk about. The horizontal axis is the x, and the vertical axis is the y. The part where they join is called the origin, and for that origin, I'm just going to make that pen a little bit thicker. For that origin, always represents 0. So I've got my 0 origin point. Now, in terms of what to put where on the axes, the first column, if you built your table correctly, should be your independent variable. That is the thing that you are investigating. So the independent variable, that first column in your table, needs to go down onto the x-axis, always. The second one, which should be your dependent variable, needs to go onto the y-axis. I'm going to delete those in a second, but we'll just talk about that for a second. Now, how can I tell? I'm not sure. Maybe I've got my columns wrong in the table. Well, this is how. When we read a graph, we read it from x to y. By that, I'm saying that x is affecting y. So I word it in the two different ways we could have this. I've either got to say the mass of baked beans I eat makes the methane, so x affects y. If I put it the other way around, I'm saying the amount of methane I produce makes me eat baked beans, which when you talk about it and think about it, that sounds silly, so it can't be that way. We say that the x-axis affects the y-axis. So I'm going to just delete those two lines that I did there, so I can go back to this. So I've got my x and y-axis, and we've decided that the mass of baked beans is going to go on the bottom. So we're going to write that down. We're going to call this a label. This is a common mistake in my writing on this. Mass of baked beans. There we go. Now, in the exam, there's quite often a question where it says label the x-axis. And what some people do is they just put little x on the axis, and that's not what they're asking for. When they say label the x-axis, they're saying which of these two data headlines do you want to put at the bottom of that x-axis. So I've put mass of baked beans there, and I'm going to put at the top, I'm just going to put methane. And it's important at this point as well, I should do this, methane, that we include the unit. So my unit for baked beans is a grams, and it is liters for methane. So we've got our two labels there, methane, and we've got mass of baked beans in grams. So that's my first job, labeling the axis and making sure I put the right variable in the right place. Next job I've got to do is I now need to put a scale onto them. So to do a scale, we've got to take our results, we've got to find the largest number. So this is quite easy because it's in a logical order. My largest number for my independent variable is 600. So what I need to do is I need to find the best way to get up to 600 in the spaces that I've got. So maybe I could go up in 50s, we'll try that. 50, 100, 110, 150, 200, 250, that's not going to work. So if I then did it via hundreds, if I did 100, 200, 300, 400, 500, 600, that works. I've got to find, and it's a little bit, I find a little bit of trial and error. If you kind of like practice it until you get that there, then you can kind of get to the right stages. So we've always got to go up in each. You can't go 0 to 50 and then 50 to 150. They've each got to be equal separations between. So we've got 100, we've got 200, we've got 300. Oh, my writing with the mouse is terrible. We've got 400, and then we've got 500. Then we've got 600. So that is a good separation between each of the numbers. It goes nicely to the end, and so we'd consider that a good scale. On my second set of data, I go up to 2.1. Now, when we get something that is not, a useful number, 2.1 is going to be difficult to go to. What I suggest is to go to the next most useful number above it. So in this case, I'm going to use 3 as my upper limit, rather than trying to get to 2.1 in stages. That's going to be harder. So I'm going to make life easy for myself. And actually, it's quite useful if my y-axis always goes over what the highest number is by a little bit. That's always quite useful. So in terms of this, we're going to go up to 3. So I could go 1, 2, 3, but that would squash my graph a little bit, and it would make it harder to see any patterns. So we want to spread it out a little bit. So I'm going to go 1, I'm going to go 2, and I'm going to go 3. Now, there is nothing wrong with leaving some bits of the y-axis above. That's no problem. It doesn't have to go directly to the top. You don't have to squeeze it in some weird kind of scale. You find the stages that make it easiest for you. So looking at my graph, I look at that. 3 was a sensible number. To get to 3, 1, 2, 3, that's the easiest way to do it in 2 big squares. So those are my scales done. So that potentially is 3 marks. 1 for that label, 1 for that label, maybe 4 marks. 1 for that scale, 1 for that scale. Next point that you can get in the exams is to be able to plot the graph and to show where each of the different points go. Now, this is very similar for those who enjoy map reading or enjoy geography. It's a very, very similar process to map reading. We've got this one here, which is my coordinate along the x-axis, and we need to match that to this column here, which is my coordinates along the y-axis. So if I look at this first one, this is saying 100. So it's on this solid line going up here, 100, and it says 0.4. So this here is 1. So I can split this up. That would be 0.5. And so here, to get to 0.5, I've got 10 squares. So each little square is going to equal half. 2 squares together equals 0.1. So I'll go up 1, 2, 3, 4 here. And there would be my first point. So that is 100 going to the along the x-axis, and it's 0.4 going up my y-axis. So we can continue this. 200, 0.6. 0.6 would be there. That would be 2 lines above that solid line. 0.6 there. 0.9 would be here. 1.2 would be here. 1.7 would be, 1.7 would be there. And 2.1 would be here. So here are my plots. I've got 1, 2, 3, 4, 5, 6 plots that each match my x column, so my dependent variable, my independent variable, my independent being the mass of 8 beans, my dependent being the amount of methane. So here is my different lines. Now, the next question will ask you to put in a line of best fit. Now, in science, this is a little bit more complicated than sometimes in maths, because maths, they tend to talk about curves of best fit. For science, a line of best fit can be straight or curved. You've got to spot the pattern that the graph is trying to show. So if I look at these results, if I try to draw a straight line, and I'll try and draw a straight line on that at the moment, so we'll go through here. Now we've got to go from 0, because 0 baked beans probably 0 methane. I'm just going to go for that. And if I put my line here, yeah, that didn't work very well, did it? Let's try that again. If I put my line here and I go across, now I could make the argument that that is a straight line. I could put that through, and I could put a straight line through it. So I could make my argument for that, and that would work. So there is my line of best fit. Notice it doesn't go through each of the points. It kind of misses some. It should go through the origin. It hasn't slightly, so let's see if I can just move it. No, it's not going to let me. So that's one argument. The other argument I could put, I'm going to put this in black, is if I go up through here and I did it freehand, there's kind of a curve going upwards. So I could say also that that is a curve. Now, it's up to you. You justify what you think the pattern is. It'll say, draw the line of best fit as you see it. So I can argue that that is an upward curve. I can argue that's a straight line. Both would work. So let's show some other examples and let's see if we can do the line of best fit here. This is a little bit easier. This is a more obvious curve. So if I get something like this, again, let's do nice. Let's go for a green color this time. So again, in this case, I'm going to start the origin. It doesn't always start in the origin. You've got to look at the data. For example, if I was going to do pulse rates and exercise, I'm hoping at 0 seconds when I start my exercise that my pulse isn't at 0. That means I've started the exercise and I'm dead. Hopefully my pulse is a little bit more. So sometimes you've got to look at the experiment. You've got to see what we're doing and the factors and decide if it goes to the origin. Now, in this case, we are going to go through the origin, and we go up, and you can see in this case, it's a nice, smooth curve that goes around. You draw it freehand. It doesn't necessarily have to go from point to point. Here's another one. Now, I've deliberately done it in this way because you'll notice sometimes with data sets we get something called an outlier. And an outlier is a result that is clearly wrong. It does not fit the pattern. It used to be called anomalous results, so you might see that as well. So an outlier or anomalous result or an incorrect result that doesn't fit the pattern. Now, they're generally quite easy to spot. In this case, it is this one here that you can see kind of sticks out of the way. Now, what do we do when we get an outlier? Well, we ignore it. We don't go to it. We circle it, we say we think that is an outlier. Put that down. And then when we draw our line of best fit, we would draw it as normal, ignoring it. Now, I've got to spot the pattern on this one, and this one, hopefully you can see, is a nice curve up and then a nice curve down. So I would be able to draw my line of best fit like that. Generally, if you are trying to draw a curve, draw it freehand. If you are going to draw a straight line, use a ruler. You've got to decide which is the best one according to the data. Now, if I go back up to this one, if I try to draw a straight line for this, like, so I'm going to do this in black and do it in this way. And you can say, well, Mr. Hardy, you said you can draw a straight line if you think of this pattern. Now, if I draw that, you're not going to get any marks for that because clearly that is not what the pattern does. On the top one, you can argue that it does go up a little bit, or you can argue that it's straight because you've got equal numbers above and below. On this one, it just doesn't fit the pattern at all, so that wouldn't work. So let's conclude. The lesson today was in several steps. The first was about the two types of graph that you can use. The second stage was to choose the right graph. Have I got continuous or discontinuous data? Therefore, I use that right graph. Second, or third, was to draw a graph and to show you how to put the scales in, the labels on the axes, plot the points, and to draw a line or a curve of best fit. Best thing for you all to do now is to do some practice. And to do this, you can get data sheets for anything, or even just do a little experiment on your own. Do number of star jumps. You can do 1 star jump, take your pulse. Do 10 star jumps, take your pulse. Do 100 star jumps, take your pulse. Doesn't matter. You can do, if you want to, the number of goals scored by your favourite football team in different minutes of a game. So you go from 0 to 90, and you can plot a graph to show where most goals are scored if you really like football. There's lots of options. So rather than me give you data, generate your own data and see if you can make a graph. There is lots of graph paper available on the internet. You just need to type in graph paper for printing onto Google, and then it gives you loads of options. Excellent. Well, thank you very much for watching. Keep safe, and I hope to do another video soon. Thank you. Bye-bye.